Hi, I'm Dave again from Purdue. And my friend Bill is here. I think he's, where are you, Bill?
I'm behind the camera, David.
Oh, okay.
Hey, David, I love this time of the year. I love fall. I love the change of the seasons and especially this time what I like most is it starts getting chillier out. And I like that. This morning when I got up, David, the temperature was 35 degrees Fahrenheit. It was chilly out.
35 degrees. That's pretty close to the temperature where water freezes.
Where does water freeze, David?
Water freezes at 32 Fahrenheit.
Huh. So, yeah, it was pretty close. Well, that would make sense. That's kind of when it snows, right? When it's below 32 degrees, a lot of times. That's usually when it snows?
Yep, that's
Okay.
when the snow can start.
Well, how do they know that it's like this morning? It's 35 degrees. How does the thermometer know it's 35 degrees?
Bill, that's a good question. In fact, I have a thermometer here. Here's an example of a thermometer. Now, this is a thermometer. It's a glass tube that has some liquid inside. There's a little reservoir of liquid, and then there's a hollow tube, a hollow channel inside this glass rod. And as the liquid heats, as it gets warmer, it expands. Bill, a lot of materials like water, metal, plastic, expand when they're heated. And that's the principle on which this thermometer works. The liquid expands, and the more it's heated, the more it expands. And we can see the scale and measure how high it goes. That's how a typical thermometer works, Bill.
Interesting. So they actually put the liquid in there and put it to different temperatures and then mark it on the scale, and then that way they know?
Sure. So that's exactly how they do it.
Interesting. Is there any way we can show the kids how this kind of works?
Sure. I think we can do something very similar to that. So, for example, I have a container of water. It's just water with food coloring. It's very similar to the little container at the bottom of the thermometer. And I'm going to put a tube. I know I'm going to make a mess. I'm going to put a glass tube down into the water. And so now I have a container that is sealed except for the water in the tube. And the end of the tube is open to the air. And so I think we can show that if we heat the water, Bill, what do you think will happen to the water in the tube if we heat this up, based on what you know?
I'm thinking back to my thermometer, and when it's hotter outside, the red liquid inside there is higher up in the thermometer. So I would think that if it's hotter, it's going to go up because you also said it expands.
Mm-hmm. So when a liquid is heated, a liquid, a metal, most common materials, they expand, they get larger. Let me see if we can demonstrate that. So I have a hot plate, just like a little burner on your stove. Let's put the water, the container of water, on the hot plate. So here's a marker, and before we start our experiment, I'm going to mark where the water is inside the tube, all the way around the tube. Okay? Now, Bill, are you ready?
I'm ready.
All right, let's put this on the hot plate and see what happens. Now, you notice that it went down slightly. That's because I moved the jar. But now that it's heating, what do you see happening?
It is definitely going above the green line.
It is going above the green line. That's because the water is...
Expanding?
Good answer, Bill. So that's exactly what would happen with the thermometer. All right, Bill, let's try the opposite effect, shall we? Let's see what happens if we go from the heat source into an ice bath. So I have some ice water here, and before I put it in, I want you to take a look at where the water level is and where the green line is. And are we ready, Bill?
I think so. I can see it.
Okay, then let's drop it into the ice water and see what happens. So Bill, I have a question for you. Why do you think the thermometer works much more quickly than having a device like this? Why do you think this one takes a longer time for the temperature to have an effect on the liquid?
I'm going to guess it's the amount of liquid inside the tube. I'm going to guess inside the thermometer it's a very, very small tube.
I think you're right, Bill. It's the liquid, it's the diameter or the size of the opening inside the glass rod, and also the amount of water in the reservoir. In the beaker, or in the jar in the ice water, there's a lot of water that has to cool down before it has an effect.
So it's still cooling that water down that's in the bottom, and the reservoir that was on the thermometer is very small.
That's true. Bill, I'm going to take the thermometer and put it in the ice bath just to see what happens. Is that okay?
Sure.
It's at about 10 degrees. I don't know if we'll see that change or not, but we'll see. You can tell me. Is it changing?
Yes, it's definitely going down. And I don't know if the kids are going to be able to see it on the video, but I definitely am seeing it go down. It's already gone down 5 degrees. And our other thermometer is still going down as well.
But a lot more slowly.
So that's how a thermometer works, right, David?
Yeah, that's how it works, Bill.
You guys have fun answering the questions. Have a good day.